Hello, today I just want to go a bit into more detail of the white paper of the DP-3T specification, and as I understood it now, it's different from the exposure notification implementation, and to me it looks better. So let's actually go back. Where was it? Here. So here you see one key thing is that the IDs are transmitted as Bluetooth low energy advertisements. So in the standard of Bluetooth low energy, there is a standard for Bluetooth beacons, and they can advertise themselves. And if I understood it correctly, you don't need an active connection between two smartphones to transfer this information, as opposed to the Google Apple standard. This is all not very much confirmed, but I just share what I've learned so far. So the advertisements are from the size relatively small. Therefore, the standard proposes to create very short-lived IDs. So those are very small in size and also valid for 1 minute. Okay, so let's consider one smartphone which is broadcasting such a short-lived ID as an advertisement, so it acts like a Bluetooth low energy beacon, and without an active connection between those two, the other smartphone can track this short-lived ID. Okay, so what you need to do is you need to start with the initial key SK, and this is valid for day 0, and the key for day 0 plus 1 is created using the day 0 key. So it's just a chain, and such an ID, you see here, it's 16 bytes because that's the technical limit of the Bluetooth low energy beacon advertisements, it seems to me. Okay, so you see here you can create a subsequent SK using a hash function and the previous day key. And then, interestingly, you can create these short-lived IDs using this function here, PRG, PRF, SKT, and broadcast key. Okay, so let's have a look how this works. So broadcast key, that is just a string which never changes, and that's common to all the participants. Okay, and then the PRF is a pseudo-random function, for example HMAC SHA-256, and that means a pseudo-random function can be parameterized, so with a seed, and the seed is your SKT. Okay, so given the SKT and this constant string, you are guaranteed to always get a pseudo-random number out of that. And then you have PRG. This is a cipher, so this is a symmetric encryption algorithm. And you see here it's producing n times 16 bytes, and n is basically 24 hours times 60 minutes divided by L. That's the length of the validity of these short-lived IDs, and in this example they use 1. So you are creating 24 times 60 of those short-lived IDs. That means for the complete day you have for each minute one of those, and those are then advertised as a Bluetooth beacon. So that's the ID. Okay, so then it's getting more interesting once you are infected. So you can imagine that you will collect those short-lived IDs when you are roaming around. And now if the doctor tells you that you are infected, what you do is you upload your SKT and the day of the start of your infection, that's something your doctor tells you, for example, to a centralized backend. But the trick here is that SKT is not traceable to your identity. That's the key. We need to make sure that SKT and your identity is not linked. Okay, so you anonymously upload SKT and the start day to the backend, and this pair here, or this tuple, is then distributed to all the participants. And then you can imagine you can, let's scroll back to here, if you have a SKT start key and this function here, you can compute all the subsequent SKTs, and using this whole function here, you can create all the short-lived IDs for a particular start date and SKT. So those are definitely a lot. So if you consider 14 days, it's 14 times 24 times 60, for example. But that doesn't matter. You can compute that on your smartphone, or your app is computing that for you. And then the only thing you need to do is, did you receive such a short-lived ID which you have created? So you create a huge list of these short-lived IDs, and then the question is, have you received one of those IDs via Bluetooth? And if this is the case, then you have been in contact with a patient, okay? So that's how it works in detail. I'm still trying to sniff on Bluetooth to find out how the app works, but I noticed that the Bluetooth component of my Raspberry Pi 3B is broken, and also the Wi-Fi, so that's part of the Broadcom chip, and I'm using an external Wi-Fi dongle, but I don't have Bluetooth on a Raspberry, so I need to order either a ESP32 or a Raspberry Pi with working Bluetooth. I have tried it on the Mac, but it doesn't work, and I've also tried it on iPhone, because I have the Fairphone, but I have an iPhone available. I've installed a Bluetooth beacon scanner, but it's not actually giving me the raw data. So that's something I need to work on, but it's just here a little update, because if I'm learning, I just want to share what I've learned. Okay, thanks for watching. That's all, and stay tuned, stay healthy, and I will tell you more once I have learned more. Bye.